So we are talking about randomized block experiments. I'll go over the uses and benefits of these experiments, an engineering-related example, and the process of how to run these experiments. Randomized block experiments are used to test how different groups of subjects, or blocks, are affected by various factors known as treatments. Examples of blocks could be anything from grade level to gender, age groups, locations, etc. But the efficiency of the experiment increases by using several blocks which account for a source of variation within the population. Once subjects are separated by blocks, they are then randomly assigned to undergo various treatments. We can see in the diagram that we start with the population, then we block the population, randomly assign each block into different treatments, and compare results much like we would with any other experiment. So let's say we wanted to test how various weather conditions affect the stability of certain materials. We would start with the population and then select groups from the population and randomize treatments. So as in the diagram, our blocks would be wood and concrete, and then we would randomly assign individuals from each block to undergo various treatments, being rain, heat, and cold. And then at the end, we would compare the results. After we run our experiment, we would organize our data into a table. We would then find the averages for each block, the wood and the concrete, and find the averages for each treatment, rain, heat, and cold. And at the end, we would find our total average, or the average of all the data, known as our grand mean. Using our data table, we can then calculate the degrees of freedom for the treatments and the blocks. We can find sum of squares, mean squares, and the test statistic f for both factors. We can then analyze the results and determine p-values for both the blocks, or the materials, and the treatments, which is the weather conditions. After finding our p-values, we can determine whether or not we can reject the null hypothesis for each factor. This would be that there is no variation between materials, or there is no variation between conditions. The alternative hypothesis would be that at least one material differs from the rest, or one condition differs from the rest. We can then see which factors, if any, cause variation between the results. Hopefully this video gave you a good idea of how to run randomized block experiments. Thank you for watching.